Welcome to Harmony Public Schools. My name is Dante, and today I'm going to be teaching you about acceleration by doing a pretty fun experiment. Now, acceleration is simply the rate at which velocity changes in an object. Velocity is a vector quantity, so that means that it both tells you the direction and the magnitude of an object. Now, since velocity depends on a reference point, say I pick this disk as my reference point. Say if I move away from the disk, my velocity is positive. And once I move back towards the disk, it's negative. Now, it doesn't mean that this is set in stone. It simply means that because I chose this disk as my reference point, my velocity is counted as such. But your reference point will either be given to you, or you will have to come up with your own reference point. And it's very important, I cannot stress this enough, to choose a right reference point and know how to interpret it, because that makes all the difference when determining in what direction the object is going to move. Now, I want to do the experiment. For this experiment, you're going to need a ramp, which I have here, a clamp to hold the ramp up, which I have right on this side, your motion sensor, a car, and a safety stopper, which I have right here, just in case that you do not catch the car. Now, before you even start this first part of the experiment, you're going to want to make sure that you have the appropriate settings. For example, my motion sensor has both a car and a human setting. Now even though not all motion sensors have this, if yours does, you will want to make sure that you have it in the right setting. If not, your experiment will not be valid. See, for me, I can simply turn the switch and that's it. I turn it from the people setting to the card setting. So very simple, just make sure that it's appropriate in yours. Now for your data collection system. I'm using a laptop with Pasco Capstone software. For your settings, you're going to want to make sure that you have it at a frequency of 20 Hertz per second, and you could see it right there. You're going to want to make sure that you have the motion sensor, that the software is actually detecting it, because sometimes you may not notice, but there are a lot of issues regarding this connectivity with the program. For your graph, you're going to want to have your velocity as your y-axis and your time as your x-axis. After this, if you make sure everything's correct, then you're set to do your experiments. For the first part, we're going to put the car approximately 15 centimeters away from the motion sensor. Now, when you indicate to your partner to start the data collection system, you're going to simply let the card go and catch it right before it hits the edge of the stopper. Now again, once again, it's just for safety, but you're going to want to catch it right before it hits the stopper. And once again, simple as that. Now, if you want to know an approximate look of how your graph is going to look, it'll be something like this. Now, why did I click this part? Because I want to expand the graph and make its value smaller, so I can actually see the change in velocity. Because in the other way that I had it right now, you can't really tell what the values are. So in this way, we can actually have a very nice visual of of the change in velocity during the experiment. Now, as you can see here, this is when the car starts rolling away from the motion sensor. Why? Because since my motion sensor is my reference point, when something goes away from it, its velocity is positive. And you could see the exact moment at which I take the card off the ramp, because you see the velocity just completely drop and disappear. Now, to the second part of the experiment. For the second part of the experiment, you're going to want to put your card right at the bottom of the ramp, right here. And just as a note to you, your settings will not change whatsoever. So if you already had your settings correctly for the first experiment, they will remain the same for the second part. You're going to get your car, you're going to roll it up the ramp, just by letting it go, and wait for it to come down. Once again, catch it right before it hits the stopper, or at least try. You're going to start your data collection system when you start rolling it up. Stop it till it comes back down. And once again, simple as that. That's very, very simple experiment and enjoyable. Now right here, you could see that the velocity is negative and then it goes to positive velocity. Why? Once again, the importance of the reference point. It just means that once the car was going towards the motion sensor, it was against my reference point. So it took it as a negative velocity. However, once it started rolling back down, it's turned into positive velocity. Again, going away from a motion sensor, if you remember the example that I had with the desk earlier. And for your graphs, for example, your teacher may give you an assignment. If you want to find the acceleration of the graph, you would do it by taking this highlighter tool right here and choosing at least 2 points. Now as you can see, I can just highlight I highlighted these points right here, and I have my slope. And a useful trick for finding acceleration from a velocity time graph is to take its slope and you have your acceleration. Now, that was it. That was the experiment. Very simple experiment, but that's the beauty of it. The beauty is in its simplicity, that you can visualize what velocity is by rolling a car down and up a ramp.